Good evening, everyone. So, I'm going to sort of play the role of walking you through some of the background information so that you understand why it's so important to be talking about transportation in a class that's focused on climate, and then Al's going to solve the problem for us. One of the things that always fascinates me about the topic of transportation and sustainability is that in the climate world, there's a lot of folks who never give much thought to transportation. And in the transportation world, there's a lot of folks who never give much thought to carbon. And so I'm hoping if we accomplish nothing else tonight that Al and I will convince you that both of those need to change, and the climate world really needs to think much more about transportation than arguably it is, and the transportation world needs to see its role as the creation of a low-carbon transportation system. Okay, so if you care about climate, you should worry about transportation. This is an exercise that was done, a peer-reviewed exercise that was done by the Jonathan Rose companies. The bottom of each bar is the traditional way of calculating the carbon footprint of a building. The top of each bar is the associated transportation carbon emissions for that building. We don't think of it that way. So what you'll see is that for most buildings, the embedded transportation carbon emissions are actually higher than the building emissions. And what you'll also see is that you can, make homes much more energy efficient, right? So CSD is a conventional suburban development, and TOD is a more transit-oriented homes, and we have 3 different types. But for each type, the benefit that you gain from traditional energy efficiency is wiped out if you don't address the transportation. So that a person who lives in a multifamily apartment near transit has a smaller carbon footprint even if they drive a gas guzzling car and have never insulated their house than than a fully energy efficient home in the suburbs where the owners are driving green cars. Okay, so got to do something about transportation. Another way of looking at the carbon, we need to think about buildings. So this is a green Walmart, right? It's LEED certified. It's the pride and joy of Walmart. And it's surrounded by acres, literally acres of surface parking lots. And all the people who drive back and forth to Walmart, all their employees, all their customers, Walmart doesn't think about their carbon footprint, but their carbon footprint far exceeds the carbon footprint of the lighting and heating systems in that building. How about your carbon footprint? For every gallon of gas your car burns, it's releasing 19 pounds of carbon dioxide, and when you do the multiplication, which is at the bottom of the screen, and I borrowed it from EPA, a typical American car with typical fuel efficiency that's driven, around 12,000 miles a year, you are releasing 4.8 million metric tons of carbon dioxide equivalent by yourself with one vehicle in your household every year, which I can assure you is probably larger than your heating and cooling carbon footprint of your home unless you live in one really big home. When we sort of go up from individuals to the sector, as Doug mentioned, transportation is about 29–30% of carbon dioxide emissions for the U.S. as a whole. Most of that comes from cars. That's what light-duty vehicles means in transportation ease. It means cars as opposed to trucks or airplanes. But what's scary about transportation greenhouse gas emissions is not how big they are, it's how fast they grow. So transportation in Massachusetts, it's actually a higher percentage because we have a fairly urbanized state and we've been doing a lot of good stuff, as I think you've probably talked about in class, on the efficiency side. So transportation is actually responsible for much more, 36%, but they're also the fastest growing share. So if you look at this slide, remembering that the sort of brass ring of greenhouse gas reduction is we're trying to get greenhouse gas levels some percentage below 1990 levels, 20%, 25%, 80% by 2050. What you can see is some of the lines, we can figure out how to make them point in the right direction, right? Residential use, electric consumption. Transportation, that line up there at the top, that's pointing in the wrong direction. And the reason that that's bad is because this is sort of the state did its baseline emissions inventory, and then last year it looked at how we've done from 1990 to 2020 in terms of moving that baseline emissions inventory. And what you can see is that the increase in the transportation sector of 3.7 million metric tons of CO2 equivalent offsets the entire savings from all of the commercial and industrial improvements we've made in the emissions inventory over the past 20 years. What's really scary about that fact is that that transportation number, as I will show you in a second, is lower than it was supposed to be in the business as usual projection. Had we achieved the business as usual projection in the transportation sector, we could have wiped out all of the improvements in residential, commercial, and industrial. This way we only took out all of the commercial and industrial. And this is why I say, if you don't care about transportation, but you care about the other stuff, you have to care about transportation, because what's the point of all the hard work we're doing in the other sectors if all of it is being offset by growing transportation sector emissions? So why do transportation sector emissions grow? Do we have any smart ideas about how to make them not grow? Okay, so transportation climate folks talk about this idea of the four-legged stool, that the total amount of carbon that's generated by the transportation system is a function of four things: cars, vehicles, fuels that we operate the vehicles with, the sort of operational efficiency of the whole system. So think about sort of sitting in traffic, right? You're burning extra gasoline, and I just told you every gallon of gasoline produces 19 pounds of carbon, so all that extra sitting in traffic and burning gasoline without even moving forward is an operational efficiency problem. And then the fourth thing is travel, right? Travel behavior. So when you first talk to transportation folks about carbon, their first reaction is, okay, vehicles I can think about, fuels I can think about, systems operations I can think about. Hopefully, all of those, we can use technology, we'll solve the carbon problem, and we won't have to touch the travel part, because the travel part is the hard part. It's like the equivalent of behavioral change in buildings, right? We'd all rather go with more insulation and setback thermostats and less making people turn the heat down, right? So getting people to travel differently is really, really hard. And so we focus on the other three first, and we only get to travel if we don't think we can actually get where we need to go. So when it comes to vehicles, the federal government is mostly in charge of that through what's called the Corporate Average Fuel Efficiency, or CAFE Standards program. States are allowed, so the idea is, right, you can't really have every state set its own rules for building cars, because you can't expect car manufacturers to sort of sell different cars everywhere. We actually have two kinds of cars in this country. We have like the cars that meet the federal standards, and then the state of California is allowed by federal law to have a separate and more strict standard, and any state that wants to can adopt the California standard. So we have a bunch of states, including Massachusetts, that require the selling of what are usually referred to as California cars. And you can see from the chart, we sort of tried to tighten up fuel efficiency standards for a while, then we kind of stopped. One of President Obama's first term accomplishments that he was able to get through Congress is that they're going to start to ratchet up again, beginning with the 2017 model year. And so we should start to see some reductions in carbon simply by virtue of the fact that the cars everybody will buy and lease will be more efficient. The next piece of the puzzle is fuels. The biggest non-petroleum fuel that we've been sort of pushing in this country is corn ethanol. This is a Department of Energy evaluation, depending on how you count it, either there's no carbon benefit from corn ethanol, or there's a modest carbon benefit, but there's not a big one. We need to kind of go to a different set of fuels. States had assumed that they were allowed to regulate the carbon content of fuels, so that while they couldn't do much on the vehicle side, other than choose to adopt or not adopt the California standards, states had actually assumed that they could, since they regulate the sales of gas in their state, and states in the past have required corn ethanol or different oxygen levels or different pollutant levels, that they could focus on this idea of decarbonizing the fuel supply. And a bunch of states, including a group of states in the Northeast, were working on adopting a regional carbon fuel efficiency standard that would sort of ratchet down. So remember, I told you, every gallon of gasoline, every time you burn it, that's 19 pounds of carbon. That's because of the amount of carbon that's in gasoline. So if you burn something that has less carbon than gasoline, in the same engine, you'll produce less carbon dioxide. Unfortunately, a court has recently suspended this whole effort to have states regulate low carbon fuels and said, no, that's actually preempted by federal law. So until that's sorted out, we're also relying on the federal government to make the rules for carbon from fuels. So the question becomes, if we do really good on fuels and vehicles, whether it's the federal government that takes the lead, or states, or a combination of the two, can that get us to the point where maybe we can sort of not have to focus on that really hard vehicle miles traveled piece of this equation? And so there was a study that was sponsored by a large number of organizations called Moving Cooler. This is the base case. So the top line is their projection for vehicle miles traveled, and the blue line, the second one from the top, is carbon dioxide, and underneath you see the sort of base case assumptions about fuel efficiency in miles per gallon and greenhouse gases based on the carbon content of fuel, and then on the bottom you see that sort of turquoise line, which is, remember, we're trying to get under 1990, right? So they did a bunch of modeling runs, and they said, what if we really ratchet down the carbon in fuel, and we really ratchet up the fuel efficiency? But there was no combination of technologically reasonable improvements on vehicles and fuel that did the job. As you can see, this is the most aggressive one. And you see that CO2 kind of gets flat there, which is certainly better than going off into outer space. But it never goes down. It doesn't turn around and go the other direction. So as long as that orange vehicle miles traveled line keeps kind of going up there, there was no modeling run in which we could rely exclusively on changes in vehicles and fuels to get where we need to go, which is to get that CO2 line to actually turn around and go down below 1990 levels. So if we want to reduce transportation sector greenhouse gas emissions some amount below 1990, 10%, 15%, 25%, 50%, it doesn't matter what the amount is, any amount, either we have to really radically transform vehicles and fuels, which there are folks working on, or we actually need to tackle the problem of vehicle miles. So, do vehicle miles traveled just go up and up and up? The interesting thing for me is, I was working at the Conservation Law Foundation with Doug in the 80s, and a lot of our work was shaped by the work of Amory Lovins, who I hope has been at least mentioned in class today. And Amory looked at a chart that looked just like that, except for it was energy use. It was primary energy use in this country in the 70s, and it just went up into infinity. And he said, that's not true. That can't be right. And so the question is, are we as wrong about the assumption that VMT grows out of control as we were in the 70s when people were saying we were going to have to build, what were the numbers, like 50 new nuclear power plants or something like that, because we just had to meet this energy demand and there was no way to have it be lower, so clearly we just needed to build more power stations. So will VMT continue to will that orange line continue to increase forever? On the energy side, Amory's argument is that there is a point at which you can decouple the use of primary energy from other indicators of economic growth. In other words, you want to grow as a country, but and the assumption before Amory was to grow, you had to grow energy use, that in order to drive growth in GDP, you needed more energy. And Amory's great insight was to say, well, no, you could use less energy per unit of GDP, and so GDP could go in one direction and energy use could go in a different direction, and he called that decoupling. And there's reason to believe that we've actually already begun to decouple the growth in vehicle miles traveled from, in this case, this was an analysis of population and real personal income, so that blue line is personal income, and you see it tracks passenger vehicle miles traveled unbelievably closely from 1970 up until the mid-1990s. The lines, it's actually hard to see the two lines, right? But then starting in the mid-1990s, real personal income is going up faster, and VMT seems to be going up a little slower, and this analysis was done through 2005, but it's been done since then, and that seems to be real. That decoupling seems to be real. In fact, some folks make an argument that you may have heard, there's an argument called peak oil, which kind of argues we've gone as far as we can on the use of oil. Well, there's a similar argument that's made out there called peak travel, which is that we've basically saturated it, that a lot of that growth in the 50s and 60s and 70s and 80s was things like every house didn't have its own car, every worker didn't have their own car, women weren't in the workforce yet, people didn't automatically get their kids' cars when they were 16, and we sort of saturated travel, at least in the US during that time. So now there literally is, in Massachusetts and in most states, one car for every licensed driver. And it's hard to have more than one car for every licensed driver, although Google's working on that at the moment. So I suppose if we have self-driving cars, we can have more cars than drivers. But until we have self-driving cars, we pretty much need somebody behind the steering wheel. And it's, you know, and a lot of sprawl, a lot of the dispersion of the places we live and work and get to every day had already occurred. So there's an argument that's been made that we've peaked that out, and so that we no longer need to expect that the amount of driving we do is automatically going to be proportionate to growth in either population or income. So this is some analysis that was done by SSTI, the State Smart Transportation Initiative, a wonderful organization that both Al and Doug have been involved with, looking not at total VMT, but per capita VMT, so that we kind of wash out the effect of growing population. And the blue line shows that there's an inflection point in the early 2000s where per capita VMT has started to come down. And the red line is actually the rolling 5-year change. So it asks the question, what direction is VMT going in? So if the red line is going down, that means that the growth in VMT is flattening out. And they asked, well, why? Maybe it's because gas is getting real expensive and people just don't want to pay that much more for gas. But this is a chart of gas prices against per capita VMT, and you know, they ran a regression, but as you can tell from just looking at it, these are not really closely related to each other. But then they looked at a second variable, which was our land use patterns in this country. And when they looked at per capita VMT and the density of urbanized areas, which had been, you know, getting less and less dense, but then starting about a decade before the change in VMT, we started to kind of flatten it out, and even that line, that red line, starts to go down a little. So the question is if we're starting to actually, if we've kind of, again, spread ourselves out over the landscape about as far as you can humanly spread ourselves out, and now we're starting to maybe be more compact, that phrase that's usually referred to as smart growth. One interpretation of this chart is that there's about a 10-year lag, but at some point, if you start getting the land use right, you start seeing changes in the travel behavior. We looked at Massachusetts data, the Dukakis Center being the lead in this particular, in a project that we call Staying on Track, which is the development of a set of regional indicators of sustainable transportation that you can find on our website. And we see that per capita vehicle miles traveled has been going down pretty steadily in Massachusetts for at least the last 5 years. And so now I'm going to go back to my question for this part of the conversation, which is, so does VMT have to go up and up and up forever? So this is what's been happening in Massachusetts. And remember, I showed you that picture of transportation sector greenhouse gas emissions kind of soaring up there. Okay, so we have these low, we can tell you where all the vehicle miles traveled, and one of the other assumptions was, well, what's really happening is that it's people in Boston or people in Cambridge. They all take the T and they're not driving as much. But in this chart, the green communities are, on purpose, the ones where a typical household can do everything they need to do in 20 or 30 miles a day. And then the blue ones, the households are driving, 70 or 80 miles a day, which is a pretty big difference, right? And what you see is, the green and tan communities are kind of all over the state. It's not just Metro Boston. So it's not, well, if you have the T, you drive less. So that's good news. So remember this chart? Remember I told you, well, actually in 2020, things weren't as bad as we feared they would be? So this is, we just simply, the green dotted line is what the transportation sector CO2 emissions were projected to be in the base case. The green solid line is what the transportation sector greenhouse gas emissions have been, real numbers from the emissions inventory, and the red line is VMT. And just to make the point, at a slightly different scale, there seems to be a pretty close relationship between VMT and the transportation sector greenhouse gas emissions. Because we have been driving less in Massachusetts, our greenhouse gas emissions in the transportation sector have been dropping since 2005, and they're not as bad. I mean, we still tell people all the time, it's like healthcare costs. We're not even up to the part of the discussion where we're trying to get them to go down yet, We're up to the part of the discussion where we're trying to get them to rise at a slower rate, okay? So the first step on driving is to get the increase to slow down, and then eventually we would like the absolute direction to turn around. But we're going in the right direction in Massachusetts, and as you saw from the SSTI data, we seem to be going in the right direction nationally. So the good news is there's hope. The idea, if you go back to those moving cooler slides, that the orange line doesn't go up and up forever and drive this, you know, unattainable goal of ever getting transportation sector greenhouse gas emissions down. We can change the direction of the orange line. So the obvious question becomes, you know, do we know how to change the direction? What I'm going to argue to you tonight is the transportation world, to drive that conversation, needs to find the equivalent of Lovin's insight, which he called the negative. So what Amory said was, you know what, nobody wants electricity. Nobody wants to use therms of natural gas, and nobody wants to fill their oil tank. What they want is illumination, light, comfort, heating and cooling, and the power to drive industrial processes. And if you can accomplish heat, light, and comfort with less energy, everyone will be happy. But you gotta have the heat, light, and comfort. So he redefined ends and means. And he said, the use of energy is the means to an end, the end is heat, light, and comfort. In transportation, we haven't made that paradigm shift. And one of the reasons is we're struggling with what the end is. What is the heat, light, and comfort of transportation? What is it we want the system to produce for us if it's not travel? So this is a quote. This is actually a 35-year-old quote. I pulled out my old copy of Soft Energy Paths by Amory Lovins. The basic tenet of high energy projection, so he was looking at the same issue but for primary energy use instead of EMT, is the more energy we use, the better off we are. But how much energy we use to accomplish our social goals could instead be considered a measure less of success than failure, right? Just as, he points out, the amount of traffic we must endure to get where we want to go is not a measure of well-being, but rather of a failure, in this case, to have good smart growth, except that term hadn't been invented 35 years ago. Well, I will tell you that transportation engineers today are still measuring failure. They measure vehicle miles traveled. They measure travel. They act as though the travel is the social utility that's produced by the transportation sector. They don't say, no, the travel is the downside, or the traffic is the downside. So Amory's next step was to say, if we're going to be serious about flipping the ends and means, we actually need to name the thing that we're trying to do, and he named it the negawatt. The negawatt is just his word for the energy savings, right? So a 100-watt light bulb is 100 watts, but a compact fluorescent bulb is 15 watts of power and 85 megawatts. Units of energy never used, right? We need the same thing in transportation. We need to say to ourselves, what is it that we're getting without driving those miles? So in thinking about this dilemma and the ends mean problem, the one place to start is, well, what does the transportation system currently think of as the end? Okay? For most transportation planners, the end is mobility. Mobility is the ability to go from one place to another. So if you think that the purpose of the system is to move people from one place to another, then of course you're going to measure movement, you're going to measure travel, you're going to measure vehicle miles traveled. Traffic congestion is an impedance to people's ability to move from one place to another. So if you're trying to fix the system, you ask the question, is congestion getting in the way of movement? And if it is, what transportation tools are at our disposal to remove that impedance in the form of traffic congestion to allow free-flowing travel? And this is pretty much the way the transportation system is planned. But the problem is we don't want to travel. I bet not one of you woke up this morning and said, I want to go 17.3 miles today, right? Many of you may have woken up this morning or thought before you went to bed last night, okay, need to get to work, need to get to school, need to pick up groceries, need to get my kid to soccer practice. But that's not the same as saying that you want to travel. You just have things you need to accomplish. So if we want to substitute a different definition of the purpose of the transportation system, if it's not going to be mobility, that thing might be accessibility, which is the ability to get the things we want. Now, sometimes to get the things we want, we have to move to them, right? But sometimes to get the things we want, we don't necessarily have to move to those things, right? So, a bunch of you came to this classroom tonight to hear this class, right? But other people are going to watch it on the web. They're going to watch the video on the web. They won't have had any VMT in order to observe, learn what went on in this classroom, right? Every time you go online and you do something, you're not traveling to get what you need. And even if you're ordering groceries and there's a little truck that's bringing your groceries, that truck is still probably traveling fewer miles to deliver groceries to 20 families than if all 20 families drove both ways to the grocery store, right? So that's the difference between mobility and accessibility. So if the end product, if the social utility produced by a transportation system is accessibility, one means to that end is clearly mobility. One way we get access to the things we need is to move, to go to where they are. But another one, and Al's going to talk about this, but not in these terms, is proximity. If you move things closer together, you improve your ability to get to those things. Among other things, you increase the number of ways to get to things that are closer together, right? If all the things you need are within half a mile of your home, you can walk to those things, you can bike to those things, you can hop on a bus to those things, or you can drive to those things. But if the closest place you can buy groceries or a cup of coffee is 20 miles from your home, you're probably not going to walk. Most people aren't going to bike. There might not be transit, and now you're down to cars. So you've got one choice instead of 4 different choices. So moving things closer together is actually a mobility improvement. And then the third category is connectivity, right? Which can be virtual, meaning I'm connected to a computer, or it can just mean that the different transportation systems connect to each other better so that I can travel without being in a car and get more places. And this is from a recent article in the Planning Association Journal. So more proximity creates more accessibility. More connectivity, that's why there's a plus sign, creates more accessibility. More mobility creates accessibility. But the other thing that's important to remember is that mobility and proximity are related to each other too. The closer things are together, the easier it is to get from one to the other. So this is the new paradigm. The problem is there's no megawatt to measure accessibility, at least not that anyone's figured out. And the reason is because accessibility isn't one thing, right? To understand accessibility, you need to know 3 things. What do you want access to? Who do you want access for? And how are they going to get there? So this is a chart that was created for Denver, which is trying to figure out how to measure accessibility, where they said, okay, parents of school-age children would like to have non-car access to high-quality schools. Well, you can map that with GIS, and you can also map low-income families on supplemental nutrition assistance, SNAP, what used to be called food stamps, their access by transit or walking to grocery stores. As long as you know to what, for whom, by what mode, you can create accessibility measures. But what we haven't come up with is kind of the overarching accessibility measure that's the equivalent of a megawatt. Okay, so a couple more minutes and then I'll turn it over to Al. So what does all this mean for actually starting to bend the curve and reduce the greenhouse gases associated with transportation? So I'm going to talk about 3 categories of proven strategies, and then Al will go into a little bit more detail on some of this. So one of them is we have 2 carbon-free modes of transportation. More or less. Walking is completely carbon-free, and riding a bike is mostly carbon-free except for the production of the bicycle itself, right? So the key to more walking and more biking is creating places where people can get where they need to go walking and biking and do so in a way that they perceive and is actually safe. And that's usually referred to as walkability and bikeability, and we now have measures of those things. The second category of things is it turns out the more you have direct ownership of a car, the more you drive. So less vehicle ownership is actually a great indicator. It's not quite a megawatt, but it is a great indicator of the availability of an ecosystem in which you can get the things you need without a car, right? So measuring how many families are doing well without cars or how much car ownership is dropping is an indicator of whether the system as a whole is providing for people's accessibility needs using transportation modes other than driving. And then finally, I want to talk about the role of transit, which is really critical. Okay, so we've done tons of, Massachusetts, if you own a car, which probably most of you do statistically, you know that every year you get a safety inspection, and every year at your safety inspection, they look at your odometer, which means that we know on a car-by-car basis how much everybody in Massachusetts drives, and that information has been shared with the Registry of Motor Vehicles in a form that allows us to use it as a research tool. So we can start to ask questions about, remember I told you there's all this variation in households in Massachusetts. We have places where households are driving 10 miles a day on average and places where they're driving in 80 miles a day. So as a researcher, we can ask the question, can we explain that variance? Because if we can understand the set of factors that create places where households are getting presumably everything they need by driving an average of 10 miles a day, right? Then we can make more of those places and have fewer places where people need 80 miles of driving a day, and that's going to lower the state's carbon footprint. So when we do the regressions, it turns out that walkability not only predicts more walking, it actually predicts less driving. And remember, that's not, I mean, it seems kind of obvious, but you could walk more but also drive more. But it turns out that if we improve walkability, we actually do reduce vehicle miles traveled, and we would expect to see carbon emissions go down. And the thing about walking is that transportation planners, the best data they have is on how people commute, because the census asks that question. And when you ask people how they commute, very few say that they walk, okay? In Massachusetts, it's under 5% of the population, because think about it, to walk to work, you have to be able to afford to live somewhere in walking distance of your work, and you also have to not move either your home or your work very frequently, right? So you're not gonna have that constellation that often, right? But it turns out that when you ask people for all the trips you make, not just getting back and forth to work, which for most people is like, 1 in 12 trips they make a week, but how do you get to others? It turns out that walking in Massachusetts, this is very recent data that we were just able to get from a state survey, is actually 1 in 5 of all trips. So walking is really, transportation planners don't necessarily think about walking as transportation. It's more like a recreational thing you do. But, if it's 1 in 5 trips in the state, it is a form of transportation, and we should be working on encouraging it. The second thing that we know is that households that either have no cars or fewer cars than workers fundamentally travel differently than households that have the same number of cars as workers. I mean, they use the system differently, they're more likely to walk, they're much more likely to use transit, and when they drive fewer miles. So their overall transportation greenhouse gas footprint is much, much lower. So again, it's not about taking people's cars away from them. It's about creating a set of circumstances under which we make it easier for households to make the choice that they do not need 1 car for every worker, and yet they can still get access to all the things they need. One of the most recent tools that actually helps advance that idea is the notion that you don't have to own your own car to be able to have access to a car on those occasions when you need it, which is usually referred to as car sharing. We now have great data on how much car sharing reduces driving. It's not obvious that it would reduce driving because a lot of members of car share organizations like Zipcar are actually people who had no car at all. Then they joined Zipcar, so the argument was always car sharing is not a carbon reduction strategy because it's basically all these 25-year-olds who didn't have a car at all and now they're driving. But that's not true. There's now really good data. It's been analyzed by Susan Sabine and her colleagues out at Berkeley. And while there's some of that going on, there's far more folks who are joining car shares and ditching their cars. So on average, every shared car in a community is replacing roughly 10 vehicles. So these 2 pictures are designed to remind us we think a lot about electric vehicles, and we need parking spaces and charging stations for electric vehicles as part of the climate plan, right? But the truth is that electric vehicle is not reducing carbon emissions by the equivalent of taking 10 cars off the road entirely. A car sharing space on the street does. This is Hackensack, which is actually on-street car sharing. You can literally hop into a car, drive to the grocery store, leave it in a different space, only pay for the 15 minutes, do your grocery shopping, come out, take a different car back home, put it in a different space. That's where we need to be moving. The last point I want to make is about transit. Because transit, and the New York MTA has been doing a lot of really good work on this. Transit reduces carbon emissions in profound ways that aren't even begun to be captured just by looking at the number of trips people make on transit. So, MTA and the American Public Transportation Association, which are actually interested in selling the carbon reduction benefits of transit, have been trying to sort of figure out, okay, how do you actually quantify what transit accomplishes? So they said, okay, so on the one hand, transit, especially buses, but also electric powered trains, they have their own carbon footprint. But then it reduces carbon in 3 ways. One is every time you're on a bus or a train, you have a smaller carbon footprint than if you were driving. The second thing is every time one of us gets on a bus or a train, there's less traffic on the street, cars are sitting in less traffic, they're not burning that gasoline and producing those 19 pounds. That's another carbon benefit of transit. But the third and most profound carbon benefit of transit turns out to be that it actually reshapes the landscape. Places where there is transit are denser and travel is less, even among the people who don't directly use the transit system, because transit is the building block for that proximity. So one of those 3 ways of achieving accessibility. So people say, you know, the T, they're running these old buses with the black smoke pouring out, and there's only 3 people on them. So really, is taking the T any less carbon intensive than driving? The answer is yes. It is. If they were fuller, the smallest ones there, the green ones, the light green, or if you could actually run all the transit vehicle full, they obviously have much less carbon intensity. But the truth is, even at their current actual utilization rate, all transit is better than driving by yourself in terms of carbon intensity. So you get a carbon improvement from shifting people out of cars and onto transit. Cognizant Center has done some work on this. The T used to carry as recently as 2000. The T carried about 1.1 million riders a day. For the last 2 years, it's consistently been carrying 1.3 million riders a day. So if you feel like it's been squishier, that's why, 200,000 extra people. Our projections are that it will minimally be carrying 1.4 million people a day by 2020, easily could be carrying 1.5 or 1.6 if, again, we could squish them all in. So that's going to have a big carbon reduction benefit for the region. The second thing is, because all those people are not on the streets, I know everybody complains about traffic in Boston. The truth is, our traffic is not as bad as a lot of other metro areas our size, and there is a real carbon benefit. Traffic would be about 27% worse if we weren't all on the T, so that's another carbon benefit. But then the big one is, we took a look at the under 3% of all, so if metropolitan Boston is defined as up to the New Hampshire border, down to Rhode Island, and out to Worcester, so it's about half the state, okay? 3% of that area is within a half-mile walk of a transit station. That's all. 97% of the region isn't. In the 3% of our region that is within a half-mile walk of a transit station, 22% of our population, 30% of all our households are. It is 9 times denser than the rest of the region, and remember, density produces fewer trips. 1 in 5 boomers in the entire metropolitan area live on that 3% of the land area. They're twice as likely to take public transportation, 3 times as likely to walk, bike, or take public transportation, and more than twice as likely to get by without a car, which, as I just told you, means they have a much smaller carbon footprint, right? So it's not that there's land use and there's transportation, which is how the transportation world has always thought about it. Land use and transportation are inseparable from each other if you care about carbon emissions from the transportation sector. It is the ability to change land use patterns by anchoring them with transit that in fact reshapes a region, that allows radically different transportation behaviors and therefore a much smaller carbon footprint. And so I think I'm actually going to stop there and let Al take over. But the bottom line is that we can reduce VOT without sacrificing what it is that the transportation sector needs to do for us in our economy, which is give us access to the things we need, not make us travel to get them. We know how to do it. We're already seeing it in Massachusetts, and a big part of the reason is the walkability of this region and our transit system. So we need to build on both of those attributes in order to continue to succeed in lowering the greenhouse gas emissions from our transportation sector.